In this demo, our focus is going to be on working with numbers in JavaScript. Since I assume that you have some prior experience with any programming language, I won't be going into extensive details about the various types of numbers, but will instead focus on getting you familiar with various number types. So just as with the previous demos in this learning path, we have a new folder containing an HTML file which is linked to a JavaScript source. On the screen in front of you, you can see the contents of the HTML file, and you can also observe that it is linked to a JavaScript source at numbers.js. So let us switch over to the JavaScript file, which is now empty. And to start off, I'm going to make use of the use strict directive. And then following that, we'll define an integer variable. So this is the variable n, which is assigned the value of 123. We will print out this variable to the console to see what it looks like. And then following that, we will redefine n and set it a value of 12.345, which is a floating point value. And we will also print this out to the console. To make sure that both of these numerical forms do indeed work in JavaScript, we can save down the source file. And heading over to the browser, I'm going to open up the HTML file. Once the page has been loaded into the browser, we can bring up the console, and we can clearly see that both the integer as well as the floating point values are accepted. So beyond integers and decimal numbers, we will now take a look at how we can express very large numbers or very small ones in JavaScript. So heading back to the source, we will see what the value 145E4 looks like. So this in fact represents the number 145 multiplied by 10 to the power 4. So this will translate to the number 1.45 million. Similarly, in order to express a very small number, we can also supply a negative power. So 145 e minus 4 translates to 145 times 10 to the power minus 4. We test it out by heading over to the browser and then refreshing the page. And the expected values are what appear in the console. We will now take a look at some more examples of implicit type conversion, which we had examined a little earlier in this learning path. First, we will print out to the console the number 20 times the string 20. And then we will print out the string 20 times the number 20. So what exactly is the output? Well, in each case, we in fact get the number of 400. So the implicit type conversion performed here was to convert the string to an int. Moving along now to a special number in JavaScript, which is infinity. And the language does in fact have a special keyword for this value, which is infinity with a capital I. So we will print this out to the console. And then beyond that, we will also access a special field which is available within the number library, which is number.positiveInfinity. We will see exactly what that value looks like when we print it out to the console. And in fact, we should obtain the same value when we divide any positive number such as 1 by 0. Similarly, there is also a negative infinity, and we will take a look at this number.negativeInfinity constant along with the output of -1 divided by 0. So by going over to the browser and hitting refresh, we can see exactly what all of these infinity values look like. So infinity as well as positive infinity return the same literal value, which is also the output of 1 divided by 0. And there is also this negative infinity literal, and this is the value which is also returned when we divide a negative number by 0. So unlike many other programming languages, JavaScript does not raise an error when you divide by 0. What you are returned is either positive or negative infinity. What happens though if we were to divide a string by an integer? So we will observe the output of that operation in just a little bit. And we will also observe that it is possible for us to define numbers using a hexadecimal literal by prepending 0x to the hexadecimal value. So the hexadecimal number EF translates to an integer of 239, and this console.log statement will in fact print out that integer value. To test these out, we head over to the console and then refresh. And we observe that when we divide a string by an integer, what we end up with is a nan value, that is, not a number. When we use a hexadecimal number as a literal in our console.log message, such as 0xef, what does get printed out is its integer value. And in fact, we can also perform a conversion of integers to various number systems by means of the toString method. So here we define a variable num and give it a value of 16. In order to view its binary value, we perform num.toString and then pass it the base of the number system for which we want the value. So the binary value, of course, will have a base of 2. Similarly, we can get the octal value by supplying a base of 8, a regular decimal value by giving a base of 10, a hex value with a base of 16, and also a base 32 value. So let's observe these by heading over to the browser, and then upon hitting refresh, we can see all of the corresponding values printed out to the console. So what the toString method generates is in fact a number, which you may consider to be rather unintuitive, but it will perform a conversion to a string if we don't supply an argument to the toString method. We will test it out by heading back to the source, and we will now define a variable a with a value of 10, and then we will use the type of operator available in JavaScript to view the type of this variable. And then following that, we will invoke the toString method without any argument on this variable a. The return value gets assigned to b, and then we invoke the type of operator on that variable. So heading over to the browser, we observe that the variable a is in fact a number, and after invoking the toString method without any arguments, it does get converted to a string. Moving back to the source, we will first define a number containing a few digits after the decimal point. So this is 3.4567, and then we will invoke the toFixed method on this variable x. This function will first perform a rounding operation to the specified number of digits after the decimal point, and will then convert this variable to a string. So the first invocation of x.toFixed should return an integer, since we specified 0 numbers after the decimal point. The second one should round to 2 decimal places, and the third invocation will round to 5 decimal places by adding an extra 0. We can confirm that by heading over to the browser, and that is precisely what occurs. So while the argument to toFixed represents the number of digits we would like after the decimal point, there is a similar function called toPrecision, whose argument is the number of digits we would like in total. So this applies to digits before as well as after the decimal point. So the first time we invoke toPrecision here, we don't specify any argument value, which means that the number will be returned as is without any formatting. In the second case, we set a precision of 2, which means that the first 2 digits, which are the most significant, will be included. So what will effectively occur is a rounding to the nearest integer. When we set a precision value of 5, the entire number should be returned as is, since it currently contains 5 digits. To confirm this, we head over to the browser, and the expected values are what we see in the output. Finally, we'll take a look at some other constants available in the number library, and these represent the maximum and minimum numerical values in JavaScript. So these are accessible as max value and min value. So we can print them out to the console. And upon heading to the browser and refreshing the page, we can see exactly what the max and min values are. Our focus in the previous demo was on working with numbers in JavaScript, and we now switch our attention to strings. So once again, we have an HTML file here, and then this points to a JavaScript source called string.js. Switching over to that, we start off with the useString directive and then define 2 different strings. We have already covered that it's possible to define strings within double quotes as well as single quotes, and we can print these out to the console just to confirm that they work. So saving down this file, we switch over to the browser and navigate to the HTML file which points to our JavaScript. Once the page has loaded, I'll just bring up the console, and both of the strings can now be seen here. So strings defined within single quotes and double quotes work in pretty much the same way. Heading back to the source, we now turn our attention to strings defined with backticks. So we have already taken a look at one example of such a string, but it is important to know that these vary from single quote and double quoted strings, in that it is possible for us to evaluate expressions within the strings themselves. So while we can substitute variables within single quoted and double quoted strings, we can straight up reference the variables themselves or even evaluate an expression within strings defined inside backticks. In this example, we reference the variable string double quotes and string single quotes within our backtick string. Note the use of the $sign as well as the curly braces. This pattern indicates that whatever lies between the curly braces is an expression which needs to be evaluated. This could also be a variable reference. To illustrate this even more clearly, we will now define the expression 1 plus 2 plus 3 within curly braces, preceded by a $sign, and all within backticks. In such a case, the expression will be evaluated to the correct value of 6, and that is the value which we will see printed out in the string. To confirm that, we head back to the browser and refresh, and that expression is correctly evaluated to 6. Moving back to our source, we will now see that when we use double quoted strings, such an evaluation of an expression is not possible. So we have the same value within double quotes, but when we save down this file and then head over to the browser, we observe that the dollar symbol, curly braces, and sum are treated as a string rather than an expression to be evaluated. It's now time to take a look at escaping special characters in string definitions. So what if we would like to have a double quote within a string itself? So here we have a double quoted string which says, I love spinach, and inside that, we would like to place the word love within double quotes itself. So is this the way we can convey our sarcasm using quotes? Well, let's test it out in the browser, and the answer is no. We can see that this raises a syntax error, and this is because the compiler doesn't quite know how to deal with these quotes without any operators around them. Well, like with other programming languages, you can add a backslash just before the quote in order to denote the fact that this quote needs to be included as part of the string and is not meant to represent the start or the end of a string definition. So we add backslash before each of these quotes, and then beyond that you will observe that this particular line is not terminated by a semicolon. So while it is standard practice to use a semicolon to terminate lines in JavaScript, this is not always required. This is because JavaScript parsers perform something known as automatic semicolon insertion. There are specific situations where that does occur, and those details are beyond the scope of this learning path. However, if you ever come across JavaScript code where semicolons are missing, you should recognize that it's not unusual practice. Alright, so let's see whether escaping these double quotes using backslashes does work. So we head back to the browser, and refreshing the page does confirm that we have successfully escaped the double quotes. Heading back to our source, we will now take a look at how exactly we can define multi-line strings in JavaScript. So for this, we'll need to make use of backticks again. You'll observe at the start of line number 22 in my code that there is a single backtick to denote the start of the string, and then we have 3 different lines over which the string is defined. So let's see how this turns up in the browser, specifically whether all of the white space at the start of each line is accounted for. And the answer is yes. So while you can define multi-line strings using backticks, you must be careful about the white space. Heading back over to the source code, we will now see 2 different ways in which strings can be defined and how you can check whether one string is equal to another. First, we define two strings using string literals the way we have so far, and both of these have the same value of David. So these are name str1 and name str2, and then following that, we define two string objects, name obj1 and name obj2, and note the use of the new keyword in order to create new string objects. This syntax will be familiar to Java programmers, where we initialize an object by passing along a string literal to the constructor. So let us now see how we can compare all of these string values. First, we will use the type of operator first on name str1 and then on the string object. And heading over to the browser, let's see what shows up in the console. So, name str1 is of type string, whereas name obj1 is in fact an object. So given that these are of different types, can we really perform some comparison operations between the two? Well, we will test those out right now. First, we will check whether name str1 is equal to name str2 using the double equals to operator. And then we will use the same operator to compare name str1 with name obj1. Third, we compare the two string objects using the double equals to sign. And then we invoke a function known as value of for each of the string objects. So let us take a look at what Boolean values are returned by these operations. So refreshing the browser page shows us that comparing the two strings gives us a value of true, since the values of both are David. In fact, when we compare name str1 with name obj1, we again get a true value, and this is because JavaScript does something known as a type coercion, where it will check for the value of the object and compare it to the string. On the other hand, when we compare the two objects, we get a value of false because it's not the values which are evaluated, but the double equal to sign in this case checks whether both of these variables point to the same object reference, which is false. On the other hand, if we use the value of function for each of the objects, it is the string values which will be compared instead, which is why we get a value of true. This covers the use of the double equal to symbol. But we now move along to the triple equal to sign, which is often used for comparisons in JavaScript. This is a little more strict than the double equal to, where a type conversion is not performed when the type of the variables on either side of the triple equal to are different. So for example, in the first of these comparisons, where we compare name str1 with name str2, the types are the same. And since these are string types and not object types, it is their values which will be compared. When we compare name str1 with name obj1, however, this will return false on this occasion. That is because there is no type coercion which takes place as it does with the double equal to sign, and this will return a value of true only if the types as well as the values on either side of the triple equal to happen to be the same. Since the types are not equal in this case, this will return a value of false. When comparing objects to objects, it is the references which will be checked for equality, and in this case, since obj1 is not the same as obj2, this will return false. The use of value of, however, will only compare the values, so that should evaluate to true. And to confirm these, we head over to the console, and the outputs are exactly as we expected them to be. In the previous video, we explored a number of operations and functions involving strings, and we will continue with that in this video as well. Let us move back to the source code now and take a look at some of the operations which are available when working with strings in JavaScript. So in this case, we define a string containing two different words, and we can get the full length of the string, that is the number of characters, by making use of the length property of the string. So this is accessible as empname.length. And then there is also an index of function which is available for strings in order to get the index of a particular character. Or if you pass along an entire string to index of, it will return the starting index of that substring if it is found within the string. In our example, the character h is found at index 6 of our string, and this is what we should expect index of to return. Now, the search function is in fact similar to index of, where the argument is a single character or a substring which we are searching for within the string itself. And if that substring happens to be found, it will return the starting index of that substring. With both index of and search, a value of -1 will be returned if the substring is not found. And the difference between the two is that search of can be used if you're searching for a particular string pattern defined in the form of a regular expression. So let's see how exactly each of these operations work. So we head to the browser, and refresh shows us the length of the string empname along with the index of h and the position at which the characters ch were found. So note here that both index of and search are case sensitive. We move along now to the use of the slice function when working with strings. So JavaScript, like many other programming languages, effectively treats strings as a sequence of characters, that is, an array of letters. So for example, the string fundamentals of JavaScript can be treated as an array containing the characters F, U, N, and so on, where the spaces are also characters. And it is possible for us to get a slice of that array using the slice function. So for example, if we invoke slice with the arguments of 1 and 12, what we will end up with is all of the characters from index 1 through index 11. The slice function is also capable of working with negative indexes, where you go backwards from the start of the string. So this particular string line is 26 characters in length, so an index of -23 effectively points to the fourth character, which is the letter D. If we pass along just a single argument to the slice function, that argument will be treated as the start of the substring which we wish to extract, and assume that we would like the full string beyond that character. So in this case, all of the characters from index 13 onwards will be included in the slice. So to confirm that, we of course head over to the browser, and we can see all of the slices of our original string right here. Alright, so heading back to the source now, we can move along and take a look at different ways in which we can replace substrings within strings. So, using the same line variable, which currently reads fundamentals of JavaScript, let's just say we wanted to replace the substring JavaScript with web programming. For that, we can invoke the replace function of the string. This accepts two arguments. The first one is the substring which needs to be replaced, while the second one is the value it needs to be replaced with. One thing to note is that the replace function does not perform an in-place replacement. That is, it will work on a copy of the string, which is why we can reuse the line string in order to perform some other substitutions. In the second example of replace, we demonstrate that the replace function is in fact case sensitive. So when we try to substitute JavaScript with lowercase j and lowercase s with the string Python, we will observe that there is no substitution which occurs. But if you would like a string substitution to be case insensitive, then we need to use a specific syntax as demonstrated in the third invocation of replace. So the first argument to replace here is not exactly a string within quotes, but is in fact a pattern where the value JavaScript is specified within forward slashes. And this is followed by the use of lowercase I to denote that the search needs to be case insensitive. In this case, we will see that JavaScript, even though it contains capital J and capital S, will be substituted with Python. In the fourth invocation of replace, we will observe that this function will only replace the first occurrence of the specified substring. So in this case, the first occurrence of lowercase a will be replaced with an uppercase A. However, if you would like to replace all occurrences of lowercase a with the capital letter, a different syntax needs to be used as demonstrated in the last invocation of replace. Once again, we place the substring we are looking to replace within forward slashes, and then we follow this up with a lowercase g to imply a global replace. So in this example, all instances of lowercase a will be replaced by an uppercase A. Alright, to test it out, we head over to the browser and we can see exactly how each of these replace invocations work. In the first example, JavaScript with a capital J and capital S is replaced with web programming. In the second case, there is no such replacement due to the case sensitive nature of replace. But when we set the search to be case insensitive, the replacement does take place and the string alters to fundamentals of Python. The first time we try to replace lowercase a with the capital letter, it is only the first a which occurs in fundamentals which is replaced. But when we perform a global replacement, a total of 4 replacements have occurred. Alright, we will now take a look at one more string function which is often used in order to split up a string into components based on a specific character. So, if you would like to split up the string fundamentals of JavaScript into separate words, then we will need to perform a split based on the space character. So we call the split function and specify space as the argument. And when we head over to the console, we observe that the words fundamentals, of, and JavaScript are available as 3 different elements in an array. So with this done, we move back to the source and explore the last of the string functions in this demo. So this is where we have a lot of leading or trailing white spaces in a string, and we wish to eliminate them. For this, we make use of the trim function. When we do this, all of the white spaces before hey and all of that before JS will be eliminated from the string, but the spaces between the words will remain. So to test it out, we again head over to the browser and we see the trim function in action. So, hey, this is JS now appears without any white space preceding or following it. Having worked with numbers and strings in JavaScript, it is now time for us to turn our attention to date types. So this is a type which allows us to work with dates in various forms, and we will see how we can initialize date variables and manipulate them. So we have an HTML file for our demo here, which points to dates.js. And switching over to that JavaScript source, we again have the useString directive, and we immediately create a new object of type date by invoking new date. So this is the variable time, and this new date object in fact carries the current time and date. We will see that when we print it out to the console. So we switch over to the browser, load up the HTML page, and when we bring up the console, we can see that this gives us not only the day of the week, but also the month specified using 3 characters, then the day of the month along with the year, and also the time in 24-hour format, along with the time zone, which in my case is Indian Standard Time, which is 5.5 hours ahead of GMT. This time zone is picked up by JavaScript from your environment. So this is the format in which we get the current date and time when we create a new date object without any parameters. However, if we did want to create a date object for a specific date and time, it is possible for us to do that. So in this case, we specify the year, the month, the day, along with the hour, minute, and second, which we want the current date time object to represent. You'll observe that for the month, I have specified a value of 09, and this is something which is not permitted when we create a new date object in JavaScript. In fact, we will see that when we save down this file and then refresh the browser page. And what we end up with is a syntax error due to the leading zeros for the month. So I'll just go ahead and fix that. So this is going to represent the 10th of September. And heading back to the browser, there is no syntax error this time. So this date represents the 10th of October 2019, and the time it represents is 15:21 and 43 seconds. The time zone, however, is taken by default to be your current time zone. Moving back to our JavaScript source, we will explore a different way in which we can initialize a date object. In this case, we use a string date format. So this is where we have the month represented as a word, followed by the date, then a comma, and then the year. So this is something which also works in JavaScript. The time in this case is automatically set to midnight. How about using the ISO standard for a date? So here we have the year using 4 digits, followed by a dash, and then a 2-digit month, a dash again, and then a 2-digit day. So this also works in JavaScript, but you'll observe that the time in this case is in fact 5:30 a.m. So even though I had initialized this with the date of October 20th, 2019, this date object is initialized to midnight for that day in GMT. So this is something you need to be mindful of when working with date objects in JavaScript, whether the date object represents your own time zone or GMT. Moving back to our source file, I'll again initialize this time variable to point to the current date and time in my time zone. So just to confirm, at the time of this recording, the date and time are Monday, December 2nd, 2019, 17:37. Now let's see what we can do with this time variable. We'll first get the difference between the current time zone and GMT using the function getTimeZoneOffset. So this will return the offset in terms of minutes. And using this time variable, it is also possible to get the UTC time in the form of a string by using the function toUTCString. To observe the output, we head over to the browser, and refreshing the page shows us that the offset, at least for me, from GMT is 330 minutes or 5.5 hours, and the negative sign conveys that GMT is in fact behind my current time zone. Also, the toUTCString function gives us the current time in UTC. So now that you have some familiarity with JavaScript's date object, we will turn our attention to the math library. This includes a lot of constants and functions which are useful when performing mathematical operations. So we have this HTML file which points to math.js. So switching over to the JavaScript, we begin by examining a couple of constants which are available in this library. So the value of pi, as well as the Euler's or Euler's constant e, are available as math.py and math.e. So again, know the use of uppercase when it comes to constants in JavaScript. So to check out these values, we load up the math.html page in the browser, and then bringing up the console, we can see the full values of these constants right here. So there is a lot of precision in each of them. Heading back to the source, we will explore the use of the round function. When we only supply a single argument, the value will be rounded to the nearest integer. So let us see what these values are rounded to. So refreshing the page in the browser, we see that 3.2 is rounded down to 3, whereas 3.8 is rounded up to 4. The rounding up also takes place in the case of 3.5. Moving back to the source, we will explore the use of the abs function in order to get the absolute value for a number. So it will take an integer or even a floating point number and then return the absolute value. Here we try it with the integers of 4 and -4. So heading over to the browser, we see that in the case of a positive number, the same number is returned back, but in the case of a negative number, math.abs returns its positive version. We now take a look at the pow function in order to calculate a power value. So to get 4 to the power 17, we pass along the arguments 4 and 17 to this function, and this is the value which is returned. Moving along, we will now explore the use of the Sqrt function in order to calculate the square root of values. Here we pass along both floating point and integer values, and we can see the square root values calculated to a great degree of precision for these numbers. So we saw that the use of the round function may round up or round down. Now there are similarly the floor and ceiling functions in JavaScript, where the floor will always round down to the nearest integer less than the given value. So rounding down 2.6 and 2.4 gives us the same value of 2. Now if we were to apply the ceiling functions to these same values, we head over to the browser and then confirm that in each case they get rounded up to the integer of 3. It is now time for us to explore the math.max function in order to find the maximum value in a sequence of numbers. Similarly, a minimum value can be calculated for that sequence using the math.min function. Note here that we are passing along these numbers not as an array, but as a sequence of comma-separated values. So, heading over to the console, we see that the max and min values are calculated correctly. Later on, we will explore how max and min can be calculated for arrays. So the math library also includes trigonometric functions. So we can calculate sine and cos values where the arguments need to be specified in the form of radians. So here we calculate the sine and cos values of 30 degrees. And note how we translate it into radians by making use of the math.pi constant. And heading over to the browser, we can see that these values are calculated to a great degree of precision once more. So similar to the sine and cos functions, the math library also includes functions to calculate the tan values and also arcsine, arccos, and so on. Now, the math library also includes a log function in order to calculate the natural log of a specified value. The natural log is of course to the base e, where e is Euler's constant. So here we print out the natural log of 3, and to view its value, we head over to the browser, and this is a value a little over 1.09. We will now turn our attention towards the generation of random numbers in JavaScript, for which I have created a new HTML and JavaScript source file. So heading over to the random.js file, we begin by invoking math.random in order to generate a random value between 0 and 1. So to view this, I'll just bring up random.html in the browser and then bring up the console. And you can see exactly what it returns. In fact, if you were to go and refresh the page, a new random value between 0 and 1 will show up. So I'll just go and hit this one more time. And in each case, it is a floating point value which is returned. But what if we wanted a random integer instead? So this is where we will need to make use of the math.floor function we took a look at previously. Here, we multiply the random value between 0 and 1, which is returned, by a value of 10. So we will end up with a floating point value anywhere between 0 and 10. Now when we apply math.floor to this, we will end up with an integer between 0 and 9, since this will always round down. So to view its effect, we head over to the browser and refresh. So the first random integer I get is 9. And note that this random integer has no relation with the previous random floating point value, since both of these are separate calls to math.random. So on hitting refresh a second time, I get an integer of 6. And on the third time, I get 6 again. And this can go on and on. Now, what if we wanted to get a random integer within a specified range? So we already saw how we can get a value between 0 and 9. But if you wanted one between 0 and 10, then we effectively multiply this random value by 11 and then apply the floor function. So math.floor will be applied to a floating point value between 0 and 11, and rounding down will give us an integer between 0 and 10. So testing this out in the console, I first end up with a value of 10 right away. So we can just hit this a few times, where we can confirm that the three numbers which are displayed have no real relationship with each other, since all of them involve independent calls to math.random. Now, what if we wanted a random integer between 1 and 10 rather than between 0 and 10? Well, we perform the same operation as when we got a random integer between 0 and 9, but then we apply an offset of 1 in this case. So we test it out in the console, and the random integers which show up in this case will never be less than 1. So we now know how random numbers can be generated in JavaScript and how we can get these values to fall within a defined range. In this demo, we will start off by going over some of the basic arithmetic operators available in JavaScript. Since it is already assumed that you have some prior programming experience, you will be familiar with most of these operators, but in some cases, the same ones in JavaScript just behave a little differently. I have this HTML file, which points to a JavaScript source. So heading over to that, let us begin by using the useString directive, and we will initialize two variables x and y and give them integer values. And before we proceed, we will just print them out to the console. So bringing up the browser and then navigating to the HTML page, I will bring up the console, and the values of x and y are now available here. Heading back to the source, we will see that when used with numerical values, the plus operator performs an addition, but when the operands happen to be strings, then it is a string concatenation which is performed. So we expect that x plus y will give us 26, and that the concatenated string will simply print out "we are learning JS." And heading over to the browser, we get the confirmation of that. Moving along now to some of the other basic arithmetic operators. There is the minus sign for subtraction, the asterisk symbol for multiplication, and if you want to get the quotient of a division operation, you can use the forward slash, and then in order to get the remainder, we can apply the modulus function represented by the percentage sign. So we will now perform these operations using 20 and 6, and these are the results of those operations. Heading back now to the source, JavaScript does provide us with two different increment operators. Here we will make use of the post increment operator, where the value of x in this case will be incremented after it has been used. When we print out the value of x, it will show up as 20, and then in the next line, when we perform an x plus plus, the value will still appear as 20, but right at the end of the line, x will have been incremented. So heading over to the browser and refreshing the page, we see that on both occasions, the value of x appears as 20. However, at the end of line number 23 in my case, when the post increment is applied, x will have been incremented to 21. So, the next time we print out the value of x, it will show up as 21. We will then examine the pre-increment operator of plus plus before the variable, and this will increment the value before it is accessed and printed out in this case. So heading over to the browser, we see the values of 21 and 22 show up. Now, similar to the increment operators, we also have the decrement operators. Here we take a look at the effect of a post decrement, and then beyond that, we will also perform a pre-decrement. And from the output, we can confirm that the post decrement does not really decrease the value of x until after it has been accessed, whereas the pre-decrement does the increment before printing out its value. Alright, it is now time for us to move on to the assignment operators. Since we will be using the variables x and y, we will just print out their raw values first, and then we will assign the value of x to y using the equal to symbol. So this should work just as you expect it to, where both x and y now have a value of 20. So while this is a basic assignment operation, it is also possible for us to perform an increment using the plus equal to operator. Here, x will be increased by a value equal to what is on the right of the plus equal to sign. In this example, we are merely incrementing its value by 1, but the benefit of using this approach as opposed to the plus plus operator is that we can increment the value by more than just 1. Let us test out, however, whether this operator works. And then, going to the browser, we can confirm that x does get incremented to 21. And similar to this increment and assign operator, there is also the decrement and assign, which we will now use on the variable y. So that has now successfully decremented to 19. We move along now to comparison operators, for which I have created another HTML and JS file. Heading over now to the comparison.js file, we will start off by initializing two variables, one of which contains the integer value of 70, whereas the other contains 70 in the form of a string. Following that, we will perform 4 different operations using these two values, the first of which involves a double equal to operation, then a triple equal to, then we will make use of the not equal to and the not double equal to. So heading over to the browser, I'm just going to load comparison.html. Then upon bringing up the console, we can see exactly what the outputs are in each case. When we took a look at strings, we saw that the double equal to just performs a value comparison and not a type comparison. And when doing that, it implicitly performs a type conversion. In any case, since both the int value and the string value are equal to 70, this returns a value of true. In the case of a triple equal to, however, this is a little more strict than the double equal to, and it checks that not only are the values equal, but also the types of each of its operands. In this case, one operand is a number and the other is a string, so this gives us a value of false. So the not equal to symbol in JavaScript is pretty much the inverse of the double equal to, and the not double equal to is the inverse of the triple equal sign, which is why you see the values flipped in this case. Moving back to our source, we will now examine the greater than, less than, the greater than or equals to, and the less than equals to symbols in JavaScript. In this case, we will again make use of the int value and the string values as the operands. So how do these work given that both of these operands are of different types? Well, we head over to the browser, and then from the console, we can see from the results of the greater than equal to and the less than equal to that these operators consider int value and string value to be equal. So there is an implicit type conversion which is performed, just like with the double equals to sign. We move along now to taking a look at logical operators in JavaScript. So we have this HTML file, and then going to the linked JS file, I'm going to start off by declaring two variables, A and B, and then using those, we perform a logical AND operation. Here we wish to perform two condition checks, that the value of A is greater than or equal to 12, and that the value of B is less than or equal to 25. So for both to be true, we can perform a logical AND, which in JavaScript is represented by the double ampersand symbol. So do both of these conditions check out? If so, we expect the sum of A and B to be printed to the console. But at this point, I will draw you to the syntax of this if statement. You will observe that there are no curly braces which follow the if statement. And when this happens, JavaScript assumes that the single line immediately after the if condition makes up the if statement body. So if the if condition evaluates to true, then this console.log statement will be executed. So bringing up the HTML page in the browser and then the console, we see that the two operations have been evaluated and the logical AND operation has been performed on those two conditions. Moving along now to a logical OR, this is represented in JavaScript by the two pipe symbols. So here we are checking whether either of these conditions, x is greater than 20 or y is less than 25, checks out. And exactly one of these conditions is true. So when we head over to the browser, the console.log statement is executed. We will now examine the logical NOT operator. So we have the condition x double equals y, which in this case will return false. But when we apply the logical NOT operator to it, it will evaluate to true. So the value of result in this case should be true. We head over to the browser now for confirmation, and that is exactly what we get. Alright, so now that we have seen the if-else statements and also played around with some of the arithmetic and logical operators, we will take a look at JavaScript's conditional statement, which is effectively a ternary operator. So this is in some ways a concise syntax for a simple if-else statement, but let us see exactly how this works. In the first of these, in line number 23, we check whether the value 100 is greater than 10. Depending on the outcome of this evaluation, there are two possible values which will be returned by this operator. And for these values, we look beyond the question mark sign. If the condition evaluates to true, the first of these values will be returned, which in our case is true. And if the condition evaluates to false, the value after the colon symbol will be returned, which is false in this case. So this is an operator which will in fact return one of these values on either side of the colon sign, and this value will be assigned to this variable condition. So let's see what the values of condition are in the console, and they show up as true and false. So just to indicate that it's not just binary values which need to be returned by the conditional operator, here we assign a variable max value to a value of either 100 or 10, depending on whether 100 is greater than 10. Since the condition evaluates to true, it is the value 100 which is returned to max value. And we can confirm that by heading over to the console, and max value does show up as 100. Previously in this course, we have taken a look at the different types which are available in JavaScript. Now we will see how we can convert data from one type to another by means of type conversions. As with all of the preceding demos, we have an HTML and JS file, and then switching over to the JavaScript, we will initialize 4 different variables. The first of these is a number, the second is a string, a boolean, and then a date object which is initialized with a specific date value. Following that, we will print out the types of each of these objects. Since we have already covered that the string value will be of type string, I'll just print out the string itself. But then we make use of the type of function for the other variables. So saving down the file and then bringing up the HTML in a browser, we can bring up the console in order to view the outputs from each of our console.log statements. You can see that the number is of type number, there is a boolean type, and the date variable is in fact of type object. Now, let us perform a type conversion. First of all, we will convert the variable num, which is of type number, to a string, and for that, we initialize this num underscore str using the string function with an uppercase S. The argument to this is the value which needs to be cast as a string. We'll then print out the type of num underscore str along with its value. And heading over to the browser, we can see that the variable is in fact of type string and that it holds the value of 25. So we have now successfully converted a number to a string. We will now go ahead and perform the reverse operation, where we will take the variable str, which is the string containing the value 350, and then cast it as a number, for which we use the number function with the uppercase N. When we do that, we will also confirm the type of str_num, and then we will print out its value to the console. And when we head over to the browser, we can confirm that the variable does indeed get cast as a number, and str_num now appears as a number of 350. The fact that it is a number is denoted by the appearance of this in purple, whereas all of the strings show up in gray in the console, at least in my case. So heading back to the source code, let us now try to cast this boolean value of true as a string. We will again print out the type of as well as the cast value itself, and we can confirm that it does get translated to a string and that its value is the string of true. Now when we try to cast this boolean value as a number, we head over to the console to confirm that it gets converted to a number, but a boolean value of true gets translated to an integer of 1. Similarly, a boolean value of false will get translated to a 0. So we continue with the typecasting. This time we translate the date value into a string, and from the console we can see exactly what this date string looks like. Now when we try to cast it as a number, let's see what this conversion does. Well, what we end up with is the number of milliseconds since the 1st of January 1970. So we have now converted multiple types into strings and numbers. And heading back to the source, let us try to convert various values into booleans. The variable num is a non-zero number, so this will be cast to a true boolean value. Str is a non-empty string, so this should also return true. The date is also a non-zero value, which is why casting it as a boolean should return true as well. And we will confirm that casting the number of 0 and a blank string as a boolean will give us a value of false. And heading over to the console, this is precisely what we end up with. So a number of 0 and a string which is blank are the ones which get translated to false boolean values. And this information can come in handy if you wish to check for 0 numbers or blank strings in an if statement, for example. One more type conversion which we will take a look at now is to see what exactly null values get translated to when we cast them as string, number, or boolean. And from the console, we can see that a null string effectively translates to the string null, a null number is 0, and a null boolean is false. When it comes to control structures in JavaScript, we have already taken a look at basic if statements, and we have also explored the conditional operator. It is now time for us to dig into loops in JavaScript, specifically while loops and for loops. So this is just going to be a quick introduction so that you get familiar with the syntax. And beyond this HTML page for the demo, we have the link JavaScript as well, which I'll switch to. So after enabling strict mode, let us create a simple while loop in order to print out all of the integers between 1 and 10. So just as a refresher, a while loop is a control structure which allows the repeated execution of some code as long as a specific condition is met. For that, we initialize a variable I to the value of 1, and then we specify a while loop. In addition to the while keyword, we follow this up in parentheses with the while loop condition. So the body of the while loop will execute repeatedly as long as the variable I is less than or equal to 10. And what do we do within the while loop body? Well, we will simply print out the value of I, and we will also increment I in each step. If you are familiar with while loops in general, you can just make a note of the syntax with the while loop condition defined in parentheses and the use of curly braces to enclose the while loop body. We can now head over to the browser to test this out. So opening up the HTML page. Once the page has been loaded, I'll just bring up the console. And the while loop has run successfully and printed out all of the integers from 1 through 10. Alright, I'm just going to comment out this while loop now using the multi-line comments. And let us generate one more while loop, this time in order to print out all of the even integers between 1 and 20. So this is an example to denote that we can have an if block inside a while block. So here, the condition which we specify for the while loop is that the value of I should be less than or equal to 20. One way to check for even integers is to make sure that I is divisible by 2, which we do by performing an I mod 2 operation, which is assigned to the variable num, and we make use of an if statement inside the while loop to check whether num is 0. If it is, the number I is even, in which case we print it out to the console. Outside of the if block though, we increment the value of I by 1 in each iteration, and you can see that this is something which will need to be done to ensure that this while loop does not go on forever. Alright, once we save down this file, we can just ensure our logic works, and heading over to the console, we can confirm that we have successfully incorporated an if block inside a while loop. In the examples we have seen so far, we have specified the condition for a while loop to terminate only at the start of the block definition. There will be occasions though where some operation performed inside the body of the while loop brings up a condition under which the while loop needs to be terminated, and for that there is the break keyword which is available in JavaScript. To demonstrate that, we head back to the source, and I'll just comment out all of the loops we have so far and then create one more while loop. In this case, we set the condition for the while loop to go on as long as I is less than or equal to 10, but inside the body of the while loop, we make use of an if statement in order to check for another condition. That is, if the value of I is exactly equal to 5, then we will terminate the while loop by invoking the break statement. When the break statement is encountered, the code execution will break out of the while loop entirely, and even if there are lines of code beyond the break statement in the while loop body, those will not be executed. So let's test out the use of the break statement by switching to the browser and hitting refresh. And we can see here that the while loop has terminated as soon as I is equal to 5. So even though the initial condition allowed the while loop to continue as long as I was less than or equal to 10, the break statement made sure that the loop terminated as soon as I was equal to 5. Moving back to our source, we will now explore the use of the continue statement. This is best explained by contrasting it with the break statement. So we use break in order to terminate the while loop entirely once a specific condition was met, which means that there were no further iterations of the while loop. With the use of continue, however, you'll ensure that only the current iteration is skipped, whereas all further iterations will go on as usual. So in this specific example, if the value of I is equal to 5, we hit continue, which means that code execution will move on to the next iteration, but all of the lines below continue within the while loop body will not be executed for that iteration. So in the specific while loop, we start off with I is equal to 11 and then continue iterating as long as I is greater than 1. In each iteration, we decrement the value of I and then we'll print out I onto the console, except when I is equal to 5. So we head over to the browser now to test it out. And you can see here that all of these integers are printed out, starting from 10 down to 1, except for the number 5. One thing to note as we head back to the source is that in both of our examples, involving break and continue, both the while condition and the if statement within the while loop body check for the value of the same variable I. This is not a requirement by any means, and each of these can evaluate entirely different conditions. Moving along now to do while loops. Before that though, I'm just going to comment out whatever we have so far. And a do while is very similar to a while loop, except in the case of a while loop, a condition is evaluated before even a single iteration is performed, whereas in a do while loop, the first iteration is always executed before the condition is checked. So that is the only difference between while and do while loops. So in this example, we are looking to calculate the factorial of a number n, and we use the variable I in order to perform iterations. The variable factorial will store the factorial value at each iteration. I won't get into the logic to a great degree, but will focus on the syntax. So the do keyword is used, followed by curly braces, within which we have the body of the do while loop. So like the while loop body, the code in this section will be executed repeatedly as long as a certain condition is satisfied. And that condition is defined after the do block using the while keyword. So the block will execute as long as I is less than or equal to n. So given that the while condition is evaluated after the do block, it means that that block will be executed at least once, irrespective of the while condition. Alright, let us head to the browser and see whether the factorial of 5 is calculated correctly. And yes, the value of 120 is correctly returned. We will now take a look at the last looping control structure for this demo, which is a for loop. Before that, I'll just comment out what we have so far. And in this case, we are generating the Fibonacci series using a for loop. Now again, I won't get into the details of calculating the Fibonacci series, except that it starts off with the sequence 0 and 1, and each new addition to the sequence is the sum of the previous two numbers in the sequence. So this requires the repeated execution of some code for a specific number of iterations. If you happen to know the number of iterations beforehand, you typically would use a for loop. In this particular example, we want a total of 8 for loop iterations. When defining a for loop for this, we can say that there are 3 different parts to it. There is the initialization of a variable where we set I to 3. Then there is the terminating condition for the while loop, which is I less than or equal to count, and the action to be performed at the end of each iteration, which is I++. This is followed by the for loop body. So let's test this out by heading over to the browser and refreshing the page. And the Fibonacci series has been generated. This course will have helped you get more familiar with programming in JavaScript, and you should have a clearer picture of the behavior of apps coded in this language. We began by delving into some of the types in JavaScript, such as numbers, strings, and dates, along with the functions available to work with such data. We then explored the use of arithmetic operators on such data, and also how logical operations can be performed. Finally, we implemented some control structures such as if-else blocks, as well as while, do while, and for loops. You now have a firm foundation upon which you can build some additional JavaScript skills. Creating and using functions in JavaScript and the use of arrays will be a logical next step in order to build upon the skills you have just acquired.